Good morning everyone. Today we are going to test for the presence of nitrate in the salt. Nitrate is an anion which is a concentrated sulfuric acid radical. As you already know, the anions or the acidic radicals are divided into three categories: dilute sulfuric acid group, concentrated group and independent radical. So nitrate belongs to which group? Concentrated sulfuric acid, right beta? Still it belongs to concentrated group. What is the starting? How to start doing salt analysis? We add? Yes, so you take a pinch of salt in the test tube. Yes, any one of you can start. So Tilak has taken the charge. He is going to take a pinch of salt available in the test tube and add dilute sulfuric acid to it. So Tilak, what are you going to add beta? Dilute sulfuric acid. Do you expect any evolution of gas or something as it is nitrate?
No.
Why? Because we know, yes, very good, because nitrate belongs to concentrated. Bring your test tube close to the mobile screen. Shake the test tube. Can you see any evolution of gas or something? No bubbles are seen. It means all the radicals of dilute group are absent, like carbonate, nitrite, sulfite, all are absent. So you can keep this test tube aside. You can wash it later on. Yes. Then you can take another test tube, and now what to do? Take the salt again, and this time we will add which acid?
Concentrated.
Yes. Yes, beta. A pinch of salt and concentrated sulfuric acid. This time he is adding. Yes. Very good. Shake it. Can you see evolution of any gas or something?
Yes, ma'am.
Is it? That is the vapors of sulfuric acid you are able to see, beta. Actually, at this step we have to be very careful, because for the concentrated group, if any gas is evolved, like if we get the white vapors, it may be chloride. If we get brown vapors, it may be bromine, or rather bromide ion. And if violet vapors, it may be iodide. But here we have not seen evolution of any kind of vapors, right? So it means for testing nitrate, it's the preliminary test for nitrate, right? We are just adding concentrated sulfuric acid. So we will heat it, because if without heating brown vapors comes, it may be bromide ion, right? And without heating, only after addition of concentrated sulfuric acid, there is no evolution of gas. It means bromide, chloride, iodide, all the negative ions of concentrated sulfuric group are absent. So we will heat it, and then what has to be added? We will be adding a paper ball. Heat it first and then add paper ball. Why we are adding paper ball? Because paper contains carbon, or any organic matter contains carbon, and carbon will work as reducing agent. It will change the oxidation state of nitrogen from +5 to +4. Now you see closely the evolution of brown fumes. No continuous heating, interrupted heating has to be done. You see how beautiful brown fumes are coming. So this is called as paper ball test. So we can even take it as a confirmatory. Some of the schools, they consider it as a confirmatory test, but it's a clear indication of presence of nitrate. But still we have two confirmatory tests. So we will keep this test tube aside and we will proceed with the confirmatory test. So Joel will take the charge, and Joel will now do the first confirmatory test. Which is the first confirmatory test, Joel? Copper chips test. Very good. So what are the steps for the same?
First we take the salt.
Yes, right. Salt, dry salt plus concentrated sulfuric acid, heating followed by addition of copper chips. Yes, a lot of sulfuric acid is not supposed to be added. A little bit. Now you heat. So salt plus concentrated sulfuric acid, gentle heating. Remove the test tube, no continuous heating. Heat and remove, then again heat. The solution should not pop out of the test tube due to continuous heating. Heat and then add copper chips to it. Copper again works as a reducing agent, same activity as your paper ball was doing. Yes, now heat. And after heating you can see again you will get the brown fumes. Shake the test tube and heat it again. Actually the brown vapors have started appearing, but in the test tube, just remove the test tube from the flame and watch it closely. A little bit greenish appearance you can see. Wait for a while beta, let it cool down. See, the solution at the lower side in the test tube is little bit bluish greenish in color. This color is due to formation of copper nitrate. Clear?
Yes.
And the vapors are of NO2 gas, reddish brown vapors of NO2 gas. So if anybody asks, it can be asked in the viva that why the solution turned blue or green. So actually the answer is it is due to formation of copper nitrate in the lower side, and NO2 gas is evolved, which is showing you the reddish brown vapors. Which is the next confirmatory test, Joel?
And the next confirmation test is for brown ring test.
Yes, brown ring test. So who will perform it? So Tilak is going to perform for the second confirmatory test, that is brown ring test for nitrate. So Tilak, what are you going to do, beta?
I'm going to add some salt.
Yes.
Aqueous solution. I have to prepare.
Yes, aqueous solution means salt plus water. That is also called as original solution of salt, right?
Yes.
Original or aqueous solution of salt means you have to take a little bit quantity of salt, a pinch of salt, and then some quantity of distilled water or plain water, whatever. Tilak has prepared the aqueous solution of the salt, which was given for the testing. Now next is what, beta?
We will add aqueous solution of ferrous sulfate in it.
Ferrous sulfate has to be freshly prepared. Why? Because if it is not freshly prepared, if you prepare ferrous sulfate and keep it aside, the ferrous ions may change to ferric, which will disturb our reaction. That is why we will have to prepare the ferrous sulfate immediately while we are doing the analysis, salt analysis. So how are you preparing the ferrous sulfate solution?
I have taken the ferrous sulfate and adding the water.
Water, yes. So distilled water or normal tap water, if you take distilled water, it is better. So your solution is prepared?
Yes, ma'am.
Okay, give it to Tilak. Tilak, come forward. Now Tilak will add this ferrous sulfate solution to the salt, aqueous solution of the salt, and shake the test tube. Now you take concentrated sulfuric acid in a dropper, and with the help of the dropper add the sulfuric acid along the sides of the test tube very slowly, and tilt your test tube, and then along the sides of the test tube you add the concentrated sulfuric acid. Tilt the test tube a little bit. Yes, slowly you add the concentrated sulfuric acid. A good quality of sulfuric acid, and wait for the appearance of the brown ring. Brown ring will appear at the junction of the two solutions. Slowly. So you can see formation of clear brown ring at the junction of the two solutions. So let us talk about the chemical reactions involved in the confirmatory test. So in the screen you can see the chemical reactions involved in the two tests. First was the copper test. In that copper test, reddish brown gas which was evolving was due to formation of NO2 gas, which you can see from the second reaction from the top on the board. And the blue solution was due to formation of CuNO3 whole twice, that is copper nitrate. And then brown ring test, which we have performed just now, the formation of brown ring was due to formation of this coordination compound, which is a complex compound. Formula is FeNOH2O whole 5 whole SO4. So this is a coordination compound whose IUPAC name is penta aqua nitrosyl iron 2 sulfate. So this was all about testing of nitrate ion. Thank you everybody.